All right, let's keep going here with this study guide, this midterm. So here we want to find an equation for the circle centered at 2, 4, and which passes through the point 3, -5. Okay, so you're given a point that it passes through, and you're given the center. Okay, so we're given the center. So the center is of the form is equal to HK, which here is 2, 4. So that means that given the equation for our circle is x minus h squared plus y minus k squared is equal to r squared. Okay, given that information, we can just go ahead and plug that in. Okay, so we can plug h and k in. So we'll have x, back to right here, we'll have x minus 2 squared plus y minus 4 squared is equal to r squared. So now we just need to figure out what r squared is. So it seems like we're almost there, and we are. We're pretty close. So, but to do that, we need to figure out what r is. So the nice part about this is that the center the radius is the distance from the center to any point on the circle. Okay, so the distance from 2, 4 to 3, -5 is going to give us our radius. Okay, so we can set r equal to the distance formula here. If we say this is point 1, this is point 2, we can plug those in for our distance formula. So we'll say then, I guess, that x1 equals 2, y1 equals 4, x2 equals 3, and y2 equals -5. So we can plug everything in. So we can have r is equal to the square root of x2 minus x1 squared, so 3 minus 2 squared, plus y2 minus y1 squared. So we'll have -5 minus 4 squared. So we'll have 1 squared plus -9 squared, or we'll have 1 plus 81, or the square root of 82. And we don't have to worry about trying to simplify that. You might be able to, I haven't checked, but the reason we don't have to is because we're just going to go ahead and square that anyways. So that means that x minus 2 squared plus y minus 4 squared equals the square root of 82 squared is basically going to be the equation for our circle. We could simplify this a little bit and get the following. We can have x minus 2 squared plus y minus 4 squared is equal to 82. And there's the equation for our circle. Okay, so here we want to evaluate the following functions. Okay, so remember, when you're evaluating a function, whatever you see in here is what you're going to plug in for the variable that your function has assigned to it. In this case, I believe x is, yeah. So anywhere you see x, you're going to plug in each of these values. Okay, so this is really quite simple. Some of them take a little bit of work, but it's not overly complicated. So we have, this will be f of a plus 2 is equal to 2 times a plus 2 plus 3. Okay, so we can distribute this 2. So we get 2a plus 4 plus 3, or 2a plus 7. Okay, not too bad. All right, so then we want to look at g of x squared plus 3. So g of x squared plus 3 is equal to 3 times x squared plus 3 squared minus 9. Okay, because remember, anywhere where we see x here, we're going to plug in this whole expression. Okay, so now we just we go ahead and FOIL this. So we'll have 3 times so let's do this off to the side over here. If we want to, x squared plus 3 squared is the same as x squared plus 3 times itself. So that'll be, if we distribute, we'll have x squared times x squared, that's x to the 4th, plus 3x squared plus 3x squared plus 9, or we'll have x to the fourth plus 6x squared plus 9. So we'll have 3 times x to the fourth plus 6x squared plus 9 minus 9. Let's distribute this 3, so we'll get 3x to the fourth plus 18x squared plus 27 minus 9. So 27 minus 9 is going to be 18. So we'll have 3x to the fourth plus 18x squared plus 18. Okay, we also want to define g of negative 3. So we'll plug in g of negative 3. That'll be 3 times negative 3 squared minus 9, or 3 times 9 minus 9, or 27 minus 9, which is 18. All right, so now for q of x is equal to x squared plus 2 over x squared. So let's go ahead and plug, we want to find here q of the square root of x minus 2. So q of the square root of x minus 2. That'll be the square root of x minus 2 squared plus 2 over x minus 2, I wrote that down wrong, over the square root of x minus 2 squared. So this will become just x minus 2 plus 2 over x minus 2. Okay, these will cancel, and we'll get x over x minus 2. Not too bad. And remember, this works because anytime you square a square root, you just undo the square root sign. That's it. Okay. Then we want to define h of negative 4. H of negative 4, that'll be the absolute value of 2 times negative 4 minus 7. So we have 2 times negative 4, that's negative 8 minus 7. Or the absolute value of negative 15, which is just 15. Remember, the absolute value sign just makes whatever the number on the inside is positive. Okay? So let's take a look. Now we can do, the other one was h of 6. So we have the absolute value of 2 times 6 minus 7 is equal to 12 minus 7, which is equal, the absolute value of 12 minus 7, which is just equal to the absolute value of 5, which is just 5. So we have 5 and 15. Okay, so next question, we want to find the domain of the following functions. Here we have f of x is equal to the square root of x minus 2 plus 6. So the domain, again, is any values that you can plug into this function and it still makes sense. Okay, so don't be tricked here with this one. Remember, when we're dealing with square root functions, the only thing that really matters is what's underneath this square root sign. We can ignore the plus 6. That's not relevant here. Okay, so all that matters is what's what's underneath the square root sign. Okay, and that has whatever is underneath the square root sign has to be greater than or equal to 0. So we can set x minus 2 to be greater than or equal to 0. And we can add 2 to both sides, and we'll get x is greater than or equal to 2. Okay, and if you want to, you can leave it like that. You can just say this is the domain, or you can say we'll have 2 to infinity as your domain. Okay, if you want to see why that fails, pick something less than 2. Plug in 0, you'll get the square root of negative 2, and then you'd have to leave the real numbers in order to find out what the solution is. Okay, so here on this next one, we have a of x is equal to 1 over x squared minus 25. All right, 1 over x squared minus 25. So we know that the denominator cannot be equal to 0. So let's go ahead and set it equal to 0. X squared minus 25 is equal to 0. Can add 25 to both sides. So we have x squared is equal to 25. We can take the square root of both sides, and we get x is equal to plus or minus the square root of 25, or plus or minus 5. So what this is telling us is that all values of x are permissible except positive and negative 5. Either of those values are going to give you a problem. To see why, just plug either of those in here, and you'll get the denominator is equal to 0, which is a problem. That's not good. So, so we can say a couple of things. We can either say we have all real numbers minus, remember the fancy r is our real numbers here, minus negative 5 and 5, and use the set notation there. Or what you're probably more familiar with from the homework, if you've been keeping up with the homework, you'll want to do negative infinity to negative 5. We'll union that with negative 5 to 5. We'll union that with 5 to infinity. Okay, and remember, we're not including any of those points here, because if we include the point, then it's a problem. So either of these would be permissible ways of writing that answer. Okay, that's a good place to stop for now.